In this video, we'll talk about quadratic equations. First, we'll talk about some concepts. We'll know that the basic form of a quadratic equation is ax squared plus bx plus c equals 0. And the solution to this equation, it is negative b plus or minus the square root of b squared minus 4ac all over 2a. And the important part of this formula is the sign inside the square root. It is called the discriminant. The results of it can be categorized into 3, and it can be greater than 0, it can be 0, or it can be less than 0. If it is greater than 0, it means there are 2 distinct results. If it is 0, it will only give us 1. If it is less than 0, it will give us none. The theory behind it is actually really simple. When we minus or add different values, it will give us 2 different values. But if we minus or plus 0, it will give us the same. And the value inside the square root cannot be negative, because we are calculating for the real values. And the other thing to take note of is the a value we have here. When a is greater than 0, the parabola is opening upward. If a is less than 0, the parabola is opening downward. Now we can start with the question. The question wants us to find the k values that the 2 equations do not meet. And because they do not meet, so this fits the third condition, that there's 0 intersections. So first we need to join the 2 equations together, because we're finding the intersection. I'll put down the second equation first. I'll distribute first for the sake of calculation. Then I'll move the x term from the right hand side to the left hand side. I'll put down a plus 4 and a plus 1 from the other side. Now we need to factorize the x so we know the coefficient of it. When we take out the x from this term, it is 6k. From this term, it is plus 3. From this term, it is negative 9k. Then simplifying the coefficient gives us 3. Now we can apply the b squared minus 4ac is less than 0. Our simplified b is negative 3k plus 3. And we'll square it. Then minus the a, which is k, and the c, which is 3. Now we'll use the binomial expansion identity. A plus b squared is a squared plus 2ab plus b squared. Our a squared will be 9k squared, 2ab will be minus 19k, then b squared will be plus 9. Then the rest of the equation will be minus 12k. Then we'll further simplify it. We'll join like term. Here we'll get minus 30k plus 9. Now we have this quadratic inequality. We can solve it by either factorizing or using the quadratic formula. I'll just factorize it. If you're not familiar with factorization, you can go ahead and use the quadratic formula. So it will be 3k minus 1 times 3k minus 9 less than 0. So when we make them 0 individually, it will give us 1/3 and 3. So when we see a parabola, our two values, the greater one will come here, it is 3. And the smaller one will be here, it is 1/3. In this inequality, we're looking for the part that is less than 0, which is this part. Our final answer will be k is less than 3 and greater than 1/3. In the second question, we need to show that the equation has distinct and real roots. To show that, we need to use the discriminant because it allows us to know how many solutions are there. So the discriminant is b squared minus 4ac because in this case we have two solutions, so it is greater than 0. We'll first put down our b value and square it. Negative 4k squared and minus 4a. The a here is 2k plus 1 from here. The c is this. We'll go ahead and simplify them. The first one, it will be 16k squared and minus 4. We'll need to use the binomial expansion identity. A plus b times a minus b. It is a squared minus b squared. Our a here is 2k. The square of it will be 4k squared. Our b here is 1, so minus b squared will be minus 1. Now I'll distribute the negative 4 into a bracket. And here we see two identical terms. It is 16k squared, but one's positive and one's negative, so we can cancel them. We'll only have 4 greater than 0 in remaining, and this proves that we have distinct and real root because this expression here is true. In question 3, we need to solve this equation. In fact, this is also a quadratic equation. It is just not as obvious. You might have noticed that the exponents of e are 6x and 3x, and this gives us a hint that this is a quadratic equation. This question requires some knowledge about indices or exponents. If you still have difficulty with it, you can check out the video in the description. Our approach is to make the two exponents more similar. To do that, we can write 2e to the 6x as 2e to the 3x times 2. It will still be the same. And minus 3e to the 3x minus 5. Here we have a rule of a to the n times m. It is a to the n to the m. So we can use this rule to write this as 3x to the 2 minus 3x. To make our calculation simpler, we can make e to the 3x another variable. I'll use u. So now we have 2u squared minus 5, it is 0. And now we just simply solve this equation. I'll factorize it, but the quadratic formula also can be used. Now our u has two solutions. It can be negative 1 or it can be positive 5 over 2. And note that the u here is e to the 3x, and we need to solve for the x. And this part requires some knowledge about logarithm, especially natural logarithm. So it is okay to stop here if you haven't learned it. So having a solution here means e to the 3x, it is minus 1, and e to the 3x, it is 5 over 2. And because any output of e cannot be negative, so our first equation has no solution. For our second equation, To eliminate the e, we can ln both sides so that ln and e can cancel. Now we have 3x is ln 5 over 2, so x it is ln 5 over 2 over 3. We can write it as 1/3 times ln 5 over 2. This is our final answer.